Okay, here we have the function 4 over x plus 1. The idea is to find the domain of the function. So if you remember, when you have a rational function, to find the domain, you need to equal the denominator to 0 because that's the restriction. So x plus 1 has to be different than 0, and then we're going to isolate the equation. So it's going to be x different than minus 1. Therefore, in this case, the domain is going to be negative infinity minus 1 parenthesis union minus 1 to infinity. Okay. Now the second step is we're going to find the vertical asymptotes. The vertical asymptotes. In this case, if you remember from class, the vertical asymptote is going to be also the restriction of the domain, which in this case we have already found it, which is minus 1. Since we haven't canceled or simplified anything, and you only have one restriction, it means that that restriction, minus 1, is going to be the vertical asymptote, but now we're going to represent it as an equation, x equal to 1, negative. Okay, x equal to negative 1, that's the vertical asymptote because it's the restriction of the domain. The next step is to find the horizontal asymptote, which in this case, to find the horizontal asymptote, we need to observe the degrees of the numerator and the denominator. In this example, the numerator has degree 0 because you have a constant. Remember, the constant, you have a degree 0. And in the denominator, you have a degree 1, which is the exponent of the x. Since in this case, the degree of the numerator is less than the degree of the denominator, then we can search for certainty that the horizontal asymptote is going to be y equal to 0. Okay, because remember, the degree of the numerator is less than the degree of the denominator, then y is equal to 0. Lastly, we're going to find the range. And the range depends on the horizontal asymptote. Since the horizontal asymptote in this case is 0 and the power is 1 in the denominator, then the range is going to be negative infinity 0 parenthesis union 0 to infinity. Okay, which in this case is like this. So we have found the 4 things: domain, vertical asymptote, horizontal asymptote, and the range. Now let's go with the second example. Which I already have here. But this time, apart from getting the domain, vertical asymptote, horizontal asymptote, and range, we're also going to find the x and the y-intercept. Okay, so the first thing, like always, is going to be the domain. Which in this case is, again, only the denominator. Different than 0. Therefore, I need to isolate, so 2x different than negative 1, x different than negative 1 over 2, pass subtraction, and then I pass dividing. And then the domain is going to be negative infinity, negative 1/2, parenthesis, union, negative 1/2, comma, infinity. Okay, that's my domain. The second thing will be the vertical asymptote. vertical asymptote, I'm going to abbreviate to VA, vertical asymptote. And again, remember, vertical asymptote is a restriction of the domain, which in this case is, we already found it, is -1/2. So that restriction is going to be also the vertical asymptote directly. Since I didn't cancel anything, I only have one restriction, that's going to be the vertical asymptote, x equal to -1/2, because it's a vertical line. Now, the horizontal asymptote, again, I'm going to abbreviate HA. This time, observe that the degree of the numerator, the highest power of the numerator is 1. The highest power, the degree of the denominator, is also 1. So the degree of the numerator, the same as the degree of the denominator. If that happens, then we're going to just divide the coefficients. What coefficients? The coefficients of the x's with the highest power. So it's going to be 3 and 2. And if we divide them, the horizontal asymptote is going to be y equal to 3/2. Therefore, the range should be -infinity 3/2 union 3/2 infinity. Okay, and like I told you, we're going to find also a part, because it's going to be useful later to graph the x-intercept and the y-intercept. Now, question: how can I find the x-intercept? Okay, to find the x-intercept, we're going to equal the whole function to 0. And if we do that, we're going to find it. So if we equal the whole function, which is 3x minus 1 divided by 2x plus 1 equal to 0, how do I solve it? Simple. I'm going to pass the denominator, multiplying the 0. I'm going to multiply anything times 0, it becomes 0. The only thing that matters is the numerator. So it's going to be 3x minus 1 equal to 0. And then isolate. So it's going to be x equal to 1/3. And we need to represent this as a point. So let's call it point A. It's going to be 1/3, comma 0. For the y-intercept, again, question: how do I get the y-intercept? Very good. We put x equal to 0. So that means that I'm going to evaluate every x with 0. So g of 0 is going to be 3 times 0 minus 1 over 2 times 0 plus 1. This becomes 0, this becomes 0, then you have only minus 1 over 1, which is minus 1. So my point is going to be 0, minus 1. Very good. Okay, now we're going to analyze the graphs. We're going to read the graphs, we're going to find the elements that we saw in class. The vertical asymptote, the horizontal asymptote, empty dots, the domain, and the range. So, in this one, observe, we have the graph of a rational function with the graph, which is this one. You have an empty dot here, vertical asymptote, horizontal asymptote. So let's find the elements. First, vertical asymptote. Vertical asymptote, VA, is going to be a x equal to 1. horizontal asymptote is this one, which is y equal to 1. We have an empty dot. Empty dot is this one. Remember, an empty dot is a hole in the graph. So we're going to use the letter G, or you can use any letter, doesn't matter. And we're going to put the coordinates, which in this case is going to be 2, 3. Lastly, we're going to find the domain and the range. The domain is going to be all real numbers except where the vertical asymptote is and the hole is located. So it's going to be domain. Okay, domain in this case is from negative infinity 1 union 1, 2, where the hole is 2 union 2 infinity. And lastly, the range. The range is going to be from below to the top, negative infinity to the horizontal asymptote, which is at 1 union 1, 2, where the hole is 3 union 3, 2, infinity. And that's it for this graph. We have found all the elements. Now, the second example, which is a little more complicated, is this one. You observe this graph. This is my function. Those are the asymptotes. And in this particular case, we don't have any kind of hole or empty dot. So let's find everything. We're going to find the vertical asymptote, the horizontal asymptote, the domain, and the range. And why not? Let's also find the x-intercept and the y-intercept, if they have any. So first, vertical asymptote. How do you find a vertical asymptote? Yes, where the vertical lines are. So there are two of them. X equal to -2, x equal to 2. But horizontal asymptote, there's just one at y equal to 1. Domain, all the values except the vertical asymptotes, -infinity to -2, union -2 to 2, union 2 to infinity. Range, be careful in this one, because observe that if you go from below to the top of the graph, there is a whole space from here, from the asymptote, there's nothing. So be careful, because in this case the range is going to be from negative infinity to where? To the -1 included, because that's where it goes and it touches that point. Union, parentheses, +1, because that's where the asymptote is. And then from there to infinity. This part of the graph, nothing here, and then goes up. X-intercept, remember that the x-intercepts, as we saw in class, are the intersections where the x-axis, and if you observe, there is no intersection, no crossing points in the x-axis, so we can just say none. And y-intercept, observe, there is one here, so you can put a letter, we're going to call it A, 0 in x, -1 in y. And that's it. There are no holes, so we have found everything.